Hey guys, how are y'all doing? How's your day going? And if it's just starting, how was your night? Hope you had or having an amazing day. And yes, the past few days have been really good. We have covered basic concepts of Python programming, we have covered string formatting, and today we're entering my best subject or my best topic or area in programming generally, control flow. Control flow is kind of like a guide to it's kind of like a guide to how your program should work. This is the thing that makes your program dynamic because it receives input and carries out different options or different operations based on what the input received is. So there are three main things. There are three main things when you're looking into control flow. You first have your conditionals. That's where you have your if else, your if and else, and then you have your loops where you have your for loops, wow, and your while loop, and finally you have exception handling where you have try, except, and finally. So let's jump into conditionals. So the syntax for working with conditionals is if um your condition statement, if condition statement and else statement. Now I can call a condition using only if. So it will not take in any else, it will not take in any else if, just the if statement. So as my program is running, it will just maybe check for the specific thing that was passed into the if, and based on what is the condition is going to continue running. I can pass the if else when I want to have two different attributes carried out. The first one will test for the if, and every other thing that is not favored from this is going to pass into the else. And finally we have the if else if. So this if you can keep calling it up to 1,000 times if you even want. So it's just if we have a lot of condition, like more than one conditions we want to test against, that's how we make use of if, if, and else. Let's take a very simple example. Let's say we have no let's do um if let's assign it into a variable first. I don't like passing them. So let's say num is equals to range, let's say 10. So this is going to be from 0 to 9. Let's now say if for I in, okay, now I've not introduced loop. uh no. Okay, if what am I doing? I don't know what I'm doing. Oh my god. If no, ah, right, let's do something more simple. I don't want to use loops yet because we're entering loops next. I want us to start working with loops firstly. So let's do this instead. Let's say let's implement what we learned last class in numbers. So let's say no name is equal to passing a string Chibudom. So we'll say if name I don't even know how to spell. If name dot is, remember is our num, is alpha, is ASCII. So let's check if it is lower, which it is. Let me just remove the second dot. So if name is lower, so since mine is in lowercase, it's going to pass in a true statement, which will kick off this condition. If name is lower, let's just print all in lowercase. Else we'll just pass it if it's not true. So the pass statement is used when, because you cannot leave your statement block empty. So you use the pass statement if you just want to say, okay, ignore this. If this is true, ignore it. Just don't do anything. Just continue with the program. So I'm not really going to dive into it because, like I said, I've been mentioning this is a crash course. So if you want a detailed course or a detailed explanation on this, let me know in the description below, and I would release a video for that. But other than that, let's run our program. I hope you have not forgotten how to run your Python program. So it sent all in lowercase because Chibudom is all in lowercase. So now I've covered conditionals. Let's go into loops. So there are two types of loops. There's the for loops and the while loop. So now the big question is when to use while and when to use for. Very tricky, but listen. When you want to make use of for loop is when you have a collection of data, usually an array or a string. So when I remember I said when I'm talking about arrays, I'm referring to things like lists, tuples, dictionaries. So usually you make use of for loops when you're working with all those stuff. So when you want to literally loop through the data that is present in that variable or in that array that you're currently working with. Then while loops, you make use of while loops, sorry. You make use of while loops when you want to test your condition against a true or false statement. So let's implement both of them right now. Let's start with our for loop. Let's create a list. So I've not created a list yet. So this is how you create a list. You assign it into a variable and call your square box. Let's just call number. So I've worked with for loop before, so we're just going to redo that. But let's make it a bit complex. So for I in A, so I say for every single element that is present in the A, that is the variable we declared, we'll print, let's print I raised to the power of 2. I hope you remember how to exponentiate. Save it. So it's going to print every single element that is present there raised to the power of 2, and it's going to just print them on the brand new line. So there we have it. That is your for loop. For loop can become more constant. Like you can have nested, like even for conditionals, you can have nested conditionals. So you have if A is true, carry out this. So when A is true, do another condition. If this is true, do another condition. So that is when it's nested. When you have multiple conditions within another condition or within a loop, or have multiple loops within another loop, is the exact once you understand the base format, it'll be easy for you to just kick off with the next thing. Now let's work with a while loop. So we can say let's call a variable and let's say a is equals to 10 maybe, right? And we can call another one and say I is, why did I put space, and say I is equal to 0. Now working with while loop, you have to test a condition. So we can say while I is greater than while I is greater than A. So another thing, when you're working with conditionals, you need to have a breakpoint, even though it's going to run for infinity. So you don't want it to just keep running forever. You want it to stop at a point. So is less than while I is less than A, we want to print out something. So let's print still running. So just say still running, and we'll increment the value of I. So let me see, there's something wrong here. Okay, so this one is not at the right. One thing Python is very sensitive to is indentation, so you need to be very cautious of that. So while I is less than a, print still running, then we're going to increase the value of I by 1. So sadly Python does not have an incrementation value, so you can't really just like like if you're working with, I think JavaScript has it also, when you just have I plus plus, so that is just increase it by 1, or I minus minus, that is reduce it by 0. So let's run that. So it's going to print. So let's count it. We should have it. I think 9 or so. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 times. Yeah, because starting from 0. So I don't know if these few examples we did helped you differentiate between what do you call it, for loop and while loop. While tests against a condition, that is while just look at while as working with boolean. While a certain condition is true, carry out this action. While for loop is when going through or working with data that is present in a given array. Okay. And finally, let's jump into Python exception handling. So when you are coding, you notice there are a lot of errors, so that you can go and just Google all the errors that are present in Python. Like you have zero division error, um, you have name error, you have, like, there are a long list of errors. So like I personally I didn't even know all of them, honestly. There's type error. I know type error is very popular. So you can go and read through all of them. but I'm going to just introduce you to a list of functions. Like this is a crash course. I just want to be sure I cover everything. So we have try. So the try block is the block that is pushing you. Okay, you, I'm try just as the name implies. Because it's so frustrating when I'm trying to define something that the name literally defines it, but I don't want to use name. Try literally is telling you to try against this given syntax, this given statement that I want you to work with. So once you try the statement, if the statement doesn't raise an error, then all is good and dandy. But if the statement raises an error, now usually if you were doing this outside the try and except block, your program will end, your program will crash. But you want to catch those errors. So you now pass except. So when you pass, let's be typing it as we're coding. So we'll say try. So I want you to try let's say let's raise a zero division, let's raise a zero division error. Let's say try let's ah, a is equals to 10 divided by 0. So we'll print a. So now we can now go and do except. How do you spell except? Except except. Okay, except. So now here after I put except, I can say except maybe zero division error. I can pass it here if I want to raise it. So that is a capital Z. If I want to catch the zero division error. But what if there are certain errors that may be raised that I would not know about? So instead of passing the errors that I want to catch, I can now just pass except. So what this except now do if no other error is passed after that is going to just catch every single error that will be sent. So, because for example, if I say except zero division error, what if another error occurs? I didn't catch that error, so my program is still going to crash. But if I say except, it's going to handle them individually. Although sometimes if you want to carry out certain actions for different, maybe you want to prompt the user to redo an input, and you know, like when you're logging, when you're signing, if maybe the issue is with your name, they tell you, oh, invalid username, but this you can do raise multiple except conditions to catch different errors, especially when you want to like communicate that error back to the user. But we're not doing anything complex now. So except, so we'll print an error code, an error code. Okay, and I'm trying to cover every single block. Next you have the finally block. So what this finally does is that this is like the code or the part of the program that must always run no matter what the situation is, whether an error occurred or not. This particular block will always run. So we can say finally and just print done to just show that the program has been completed. So let's save this. After I've run this, I'm going to introduce you to raise. So you can see it printed out an error code because we had a zero division error. So now let's try and work with it without any error of some sort. So you can see it printed out the output 5.0 and it just printed out done. Now my code is running perfectly right. What if I want to get an error? So that's when this raise comes in handy. So now the raise works quite similarly to except. You can raise a specific type of error or you can just raise an error. So let's just raise an exception. So we'll do raise, then we'll just raise an exception. And we can maybe pass in an error code of some sort, so maybe an error code also, but the except will surely pick up the error, so you can even leave it blank if you want. So let's save this. So even if there's nothing wrong with my code, I've raised an error, so surely I'm going to pick up an error. So we have an error code. So even though if I were to this one, the print statement came after. So if I were to just cut this print now and put it below where I raised the exception, that 5 point should disappear from them. So let me cancel out this extra indentation. Okay, let's run it. And you can see my 5.0 is missing now because the exception was raised before the code finished. So usually it tries to catch the error immediately is being raised to avoid your program from crashing. So yeah, That is everything you need to know for control flow. So we covered conditionals, we covered loops, and we covered exception handling. If you have any other question that you'd like us to relating to this, feel free to leave it in the description below. Every single link and all the documents that will be needed for you to understand this course better will be linked in the description below. So feel free to check it out. Don't forget to like this video, share it to people who you think this video will help. And if you would like a full and more detailed explanation of what we just covered here, do let me know. And I can't wait to see you all here tomorrow. Have a beautiful rest of your day. Bye, guys.